Okay, we're going to continue our conversations with the square root function. The first thing we're going to look at is we're going to look at some transformations of the square root function, and we're going to talk about the domain range and how that changes. We're actually going to do it in interval notation, then we're going to do the domain range as an inequality. So the first one, we have x plus 5. Now I'm going to go in here and I'm going to draw in the parent function. Remember the parent function, let's talk about the parent function real quick. So this right here is the parent function of a quadratic. We have 1 squared is 1, 2 squared is 4, negative 2 squared is 4, 3 and 9, and 3 and 9. So what we're doing is we're taking this, we're doing the right side of this, the positive side, and taking its inverse. And that's how we get the square root function. In the square root, we take these numbers and flip them. So here we have the 1, 1. We have, instead of 2, 4, we have 4, 2. And instead of 3, 9, we have 9, 3. That's why it looks like this. So remember that none of these are changing this slope or steepness of this line. So those numbers we're going to use. This is 1, 1. This is 4, 2. And this is 9, 3. So when we graph these, we're going to use these perfect squares on our x-axis. Alright, so here's that parent function. The parent function of bet 0, 0. And remember, that first one we do is 1 to the right, 1 up. The second one is 4 to the right, 2 up. 1, 2, 3, 4. So that's what the parent function would look like. We're going to have to change that. If it's in the parentheses, in the absolute value, in the square root, that same conversation we keep having, that moves it left and right. So inside the square root moves it left to right. And since it's inside, we move it the opposite direction. Positive 5 would typically move right, but since it's inside the parentheses, it's actually going to move it left. It's going to move it left 5 from the origin. 1, 2, 3, 4, 5 to the left. And then we keep this same pattern. 1 to the right, 1 up. 4 to the right, 1, 2, 3, 4, 2 up. 5, 6, 7, 8, 9 to the right, 3 up. There's my new function right there. Let's go ahead and try to figure out the domain range for this. My domain, let's go ahead and start in interval notation. Interval notation, we find the smallest value. Smallest value, domain is my x's. So my smallest is on the farthest to the left. The farthest to the left it goes is negative 5. And then it'll go to my farthest to the right. Farthest to the right, well, this goes on the right forever and up forever. Those are both infinity. So the biggest number it goes to is infinity. How do we write that as an inequality like it's asking for? So domain is my x, and it's everything greater than negative 5. X is greater than or equal to negative 5. Let's go ahead for the range. Range is my y values, the up and down. What's my smallest y value? Smallest, nothing, 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 nothing. Oh, right here. Smallest one is 0. Largest, and again this arrow means it's going up and to the right forever. So the largest up here is infinity. If I write that, well, range is y, and it's going to be greater than or equal to infinity. Alright, let's look at the next one. The next one has some different changes on there. I'm going to go ahead and draw in the parent function just to make it easier to see what is happening. Go ahead and draw that parent function to make sure we see what's happening. Okay, this 3. Now this 3 could also be at the end, and it would be plus 3, like that. It's not in this equation. but it could be over here. It'd be fine if it was. That 3 at the end, it's not the y-intercept. It just says, hey, we're moving this 3 up. 1, 2, 3. And then we have a negative. If we have a negative in front, it's going to drop it. It's going to open down like this. So instead of 1 over and 1 up, we're going to go 1 over and 1 down. Next one will be 4 over and 2 down. 1, 2, 3, 4. 1, 2 down. And next one will be 9 over and 3 down. That's an arrow. That means it goes down to negative infinity and will go right to positive infinity. Let's go ahead and figure out the domain and range. Domain for this, we're going to have smallest x value. What's my smallest x value? 0, and that's going to go to infinity. As an inequality, my x will be greater than or equal to infinity, and then we'll do the range. Smallest range value. Well, if I look down here, it keeps going. It says it keeps going until negative infinity the way I have it written. So my smallest value would be negative infinity. And then it'll go all the way up here until we get to that 3. Include that 3. So that'll be y is less than, different sign there, 3. Is everything less than 3? Alright, next ones. We're going to graph these and we're going to figure out the x and y intercepts. We're going to graph them and talk about the x and y intercepts. I would prefer you give me exact answers and everything. I don't want it estimated or decimals unless it asks. So find the x and y intercepts after graphing these. We're going to go ahead and we're going to plug in some values here. No, actually, let's just graph this and we'll plug in values. Alright, so this, we're going to move over. This says plus 2. That means it's going to go left 2. Then we use that same pattern we used up here. Right 1, up 1. 4 to the right, 2 up. 9 to the right, 3 up. So we're going to go 1 to the right, 1 up. 1, 2, 3 to the right. Sorry, 4 to the right, 2 up. And the other one will be off the chart there. So there's my function. Has an arrow over there if we're doing domain range. X and y intercepts. So for my x intercept, that's pretty simple. It's right here. We know it's on this point. We've simply moved it over. Alright, for the x-intercept, we know it. It's right here. It's straightforward. That's negative 2. But for the y-intercept, there's no point here. I still want an exact answer. Well, to figure out what we want to do here, let's go ahead and look back at the x-intercept. I know my x-intercept also has a point. This point is negative 2, 0. So if my y-intercept, it also has a point. And that point always starts with 0 because that's my x value. So what I want to do is I'm going to put this 0 in here for x. So if I come over here, I'm going to put 0 plus 2. The square root of 0 plus 2. What's the square root of 0 plus 2? So that's the square root of 0 plus 2 is 2. So that's the square root of 2. I can't simplify a square root of 2. So that point right there is 0, the square root of 2, meaning my y-intercept is the square root of 2. Exact answers, I don't need you to estimate them. Please. Number 4, it has a couple different changes on here. Unlike the other ones where they just moved up or it just moved left, maybe flipped around, this one's actually going to move up and down, left and right, and change direction. So the 2, the positive 2 on the outside says it goes up 2, 1, 2. The plus 1 in there says it moves left 1. And there's that point. The negative says it opens down. So 1, 1, 1, 2, 3, 4, 2, 4, 5, 6, 7, 8, 9, 3. That's what that one looks like. X and Y intercepts, they're pretty straightforward. X intercept is right here. It crosses at 3. Y intercept, and that crosses at 1. And again, if we wanted points, X intercept would be 3, 0. The Y intercept would be 0, 1. X intercept, Y is 0. Y intercept, X is 0. Every time. 5 and 6. If we think about 5 and 6, I'm going to graph them, and then we're going to talk about how we figure out what the minimum maximum would be. So as I graph this, I only graph in that interval between 0 and 5. So here is 0, there is 0, and here is 5. So anything outside of that box, I don't care about. I could care less if it exists or not. Let's go ahead and graph her. So it's negative, that means up and down. There's a plus 2 in here, which means it's going to go left 2. No up or down movement in this one at all. So we're going to start left 2, open down 1, 1. Then we go 1, 2, 3, 4, down 2. 4, 5, 6, 7, 8, 9, down 3. So this is going to be something like that. That's what it's going to look like. But I don't care about anything except what's in there. And if I look at my graph, I will notice that it's always going down in this interval, which means that this point right here has to be my max, and this point right there has to be my minimum. Has to be my maximum, has to be my minimum. So I only care about those points. So when I'm finding maximum and minimum between in an interval, I only need to figure out those 2 points. So let's find 0. I'm going to plug in negative the square root of 0 plus 2. And then we're going to do 5 as well. Negative the square root of 5 plus 2. 0 plus 2, what do we get? 0 plus 2 is 2, square root of 2. Can't do anything to the square root of 2, that's what that one is. For 5, I plug in 5. 5 plus 2 is 7. Negative the square root of 7. There's no math for us to be done. Those are my minimum and maximums. My minimum would be this lower one over here, this lower one. This one is 5. At 5 we got negative the square root of 7. My max would be this one over here, the higher of the two. That would be negative the square root of 2. Let's do another one. What's my interval on this one? My interval for this one is 1 to 2. Here is 1. There is 2. I only care about that interval there. Let's see. We can put in our changes here. This has moved right 1 and up 4. Right 1, up 4. So that's where I start. And then it is positive, so it goes up 1 over 1. To the right 1, 2, 3, 4, and up 2. That's all I really need for this. So it's going to look like. My max and min are going to be pretty straightforward because they are going to be whole numbers. I actually have points I drew where it crosses those lines I made. This is my minimum here at 4. It's my maximum here across at 5. So this is what we need to look at here. If you look at these right here, these top two are talking anything with domain and range. These middle two are talking anything with x and y intercepts. The bottom 5 and 6 are talking about anything with intervals. On the back page, we have a square root function that has both x and y intercepts. So if I'm talking about x and y intercepts, I'm trying to prove that's true, look at your x and y intercepts. See if you can think of an example here that doesn't have it. So let's do this one to see an example of how we're going to do 7 through 11. For 7, it says a square root function has both x and y intercepts. And in case we haven't read the directions, it says determine whether each statement is always true, sometimes true, or never true. So a square root function has both x and y intercepts. Here's where we're talking about x and y intercepts. Let's think about it. X and y intercepts are when it crosses the x or the y axis. So can this happen? So yes, this can happen. We actually have two examples of it. Can we think of an example where this would not happen? Well, let's see if we can come up with one. Where could I move my square root function to where it would have no x and y intercepts? Well, if I move it up and to the right, is it going to cross the x and y axes? No. So this can happen, but it sometimes won't happen. So that means it will be sometimes true. That's how we're going to do these. Here it says the range of a square root function includes positive and negative real numbers. So the range, up and down, positive and negative. I'll let you think about this one. This range includes positives. This range here includes negatives. I'll let you figure out what you think that answer is. This one right here. This A means that it is moving up or down. That's this A right here. It moves up or down. Also, we didn't talk about, so I don't know why it's thrown in here, but this negative in here means it goes that way. The negative inside the square root says it turns left instead of goes to the right. Goes to the left like this. So again, you're moving it up and down. This function, up or down with A. Is it always going to be in quadrant 2? Is it sometimes going to be in quadrant 2? Or will it never be in quadrant 2? X and Y intercepts. For the next one, look at your X and Y intercepts. For 11, the domain, again, we're moving this left and right. Is it always going to be, is it always going to include positives, never include positives, or always include positives? I'll let you think about that one. 13, 14, 13. All we're doing for 13, I'm going to leave this up here. This 12 needs to be put in here for X. This is the only one you really have to put in the calculator because it wants you to estimate. And then 14, it says interval. And this one, there is some rounding. I think on one of these you have to round it. This is just like numbers 5 and 6. 5 and 6 on the back. All you're doing is plugging in the interval, just like on the front page. And 15, I'll leave it to decide what you want to do with that one. This is due by the end of the period. I would start with 13 and 14 because you can plug those in the calculator, and then you can work on these. It's mostly thinking. If you have any questions, let me know.